Welcome to Machine Learning with Python. My name is Richard Kirschner, and I'm with Simplilearn. You might be new to machine learning or Python, or maybe you're concerned that they're difficult and complicated to learn. Don't worry. By the end of this tutorial, we'll go over the basics and have you writing a couple of simple scripts to use machine learning in Python. Before we dive in, let's take a look at our agenda for today. We're going to start with why use machine learning and applications of machine learning. We'll follow that up with how machine learning works and machine learning workflow. Once we've gotten through these 4 points, we'll show you the tool Anaconda. This allows you to do some Python scripting and where to download that from. And then we'll get back into more detail as to exactly what kinds of machine learning there are. And finally, we'll do a linear regression demo and a k-means clustering demo where you actually get to write a couple scripts and get your hands dirty and do some Python work. And finally, we'll wrap it up with a use case weather analysis. So let's get started with the first 2 bullet points. Why use machine learning and applications of machine learning? Why use machine learning? Before we get too deep into this, let's look at a simple use. Now we'll use the example of PayPal, which uses machine learning to detect fraud. So what PayPal does is it uses this different machine learning tools. And before I started using machine learning, a lot of people were getting by with a lot of scams. And then once they figured it out, they said, hey, we need a tool in here that's going to be automated and easy to use and reliable. And so they found the machine learning tools came in, and then they were able to stop the different fraud. Now, we're going to answer why use machine learning after we look at applications in machine learning. Applications of machine learning. In the applications of machine learning, we have search engine results, we have voice recognition, we have number plate recognition, we have dream reader. If you think hard enough, you'll find that this small sampling is just the beginning. From automated cars to scientific discoveries, any of these things are all part of today's world of machine learning. And let's take a look at the search engine, the first one. Imagine if you were at Google or Bing or Yahoo.com and you typed in a search to one of those, and that goes across to somebody and they look at it, they have to read it. Then they go to the library, they look up the information, they come back, and then they type back the answer to you, which might or might not be correct depending on which person you got. One of the things we notice right off the bat is that's not what happens nowadays. Nowadays, you get very reliable information, you get it fast, it's automated, and as time goes on and we get more information, the search engine returns better and better results. This is true of voice recognition, where it gets better and better at recognizing what we're saying and able to transcribe that for any of your Google commands or home devices where they recognize your voice, or maybe it's Siri if it's iPhone. We see that in number recognition. We see that in being able to read things back to us like Dream Reader does with news things. So, as we're looking at applications of machine learning, we want to take away that the use of machine learning, or why use machine learning, is because it helps make life easier. It helps our processes be more consistent and reliable. Now that we have an understanding of why machine learning, let's go take a look at how machine learning works. We have phase 1, which is learning. That's broken up into 3 different steps. The first step is you need to clean the data and format data. That's your pre-processing. What does that mean? Well, computers nowadays aren't too smart when it comes to figuring out the difference between a picture or text when you send it in. So the first thing you do is you usually clean the data so that all your pictures are in one file and your text is being processed separately. And that's all part of the pre-processing. If you try to process text like you do a picture, you're not going to get the right answer, and vice versa. Once you've pre-processed the data and you have it nicely cleaned, then we're going to go in and start learning. Take that data and learn from it. And there's what they call supervised and unsupervised data in the learning. And we'll talk about that more later on. There's even a third field in there. And finally, we get into testing. So once you've gone through this process, you've trained your machine learning so it works correctly. You need to test it and make sure you're getting the right answers out of it. Once you've gone through all that, then you move to phase 2, which is actually using it or putting it into commercial use, and that is to do a prediction. And on there you now have your trained model and your new data come together, and output is going to be a prediction of what you're looking for. We see that in the form of predicted data. Let's take this and let's see what it looks like as a workflow. So let's take a look at the machine learning workflow. If you're doing any project, the first thing you want to do is define an objective. Not just machine learning, but in life in general. In machine learning, once you defined the objective, then you have to prepare the data. Remember in our last slide we talked about cleaning the data. Well, that's where you're preparing the data. You want to make sure you understand what's coming in. Make sure that you have the right data mixed with each other. Make sure you have the proper schema. That way you know what tools to use. Once you've prepared the data and you have an idea of what's coming in, you need to go ahead and collect the data. Once you've collected the data, you select the appropriate algorithm to work with that data, and then you take that selected algorithm and you pass it to train the model. Now, once you've done the train on the model, you want to test it, and what happens with the test is it might come out incorrect, so you might have to change how you train the model. And if that doesn't work, you might have to go back and say, okay, I selected the wrong algorithm to do this. Let's pick a new one that's going to work. And once you've gone through all of that and you have a test model that works, then you can put it out for production and start using it to predict things. Now that we've taken a couple looks at the steps to setting up machine learning and the process, let's take a little detour. We're going to need a tool to do this in, so let's look at downloading Anaconda. Now, Anaconda, which utilizes Jupyter Notebooks, is one of the top tools used by data scientists. It's one of my favorite ones. It's also very easy and simple so that anybody who's developing a program or script can use it to get right in and jump ahead. Now, Anaconda, which you might also reference as Jupyter Notebooks, because it's part of that, and we'll show you in just a minute, it's part of that group of programs and applications, is a wonderful tool. And it is used by both people who are just beginning and starting out in Python or data science, all the way to advanced people and professionals. It's a very powerful tool to test your scripts in, and it's very easy to use. To download Anaconda, you'll want to go to www.anaconda.com. Once you're on that page, you'll see a button on there that says Download Anaconda. This will take you to another page where you can select the version of Anaconda and the version of Python you want to use with it. If you're just new and starting with Python, you'll want to use version 3.6, which is the most current version. For people who have been using Python and they have older modules they might need, you can also download Python version 2.7. And once you're in Anaconda, you can also add new versions on there if you need to. Once you've downloaded the appropriate version of Anaconda, you'll want to go ahead and open up the installation file by double-clicking on it and go through the installation. You'll see here the Welcome to Anaconda 5.0.1 64-bit setup. This wizard will guide you through the different steps. Throughout the wizard, unless you have a special setup, you can go ahead and just let it select the defaults. And once you get to the end, you can go ahead and click on Install to start the installation. Once you have installed Anaconda onto your computer, you'll be able to find Anaconda prompt, which will open up a window. In this window, you'll type Jupyter Notebook, that's Jupytr space notebook. You might also have the Jupyter Notebook startup in there too, which will do this automatically for you. Jupyter Notebook will then open up your default browser window. Well, you'll then have your running Anaconda through Jupyter setup, and you'll be able to select New in Python. You'll see on the upper right hand corner you'll have a New button, and you'll have a drop down where you then select Python 3, or if you installed it, Python 2.7. Once you've opened up your new Python notebook, you'll have a line you can type in, and you might want to just try a quick script in Python, print. In this case, you'll say print this line will be printed. And then when you hit the play button, you'll see this line will be printed. Let me show you these last two steps in my own Jupyter Notebook in Anaconda. As you can see here, I have my web page open, and it's opened up to Jupyter. When I go to the upper right hand corner where it says New, I click on that, it gets a pull down menu. And then I click on Python 3 and it opens up the Python 3. Once I'm in here, I can now type in the top line, print, brackets, quotes, this will print below. When I go up and hit the play button, it executes this line of code. This will print below. I then have another line below, and whatever I've run above, whatever I ran in the first line, if I put in like x equals 5, that information carries on down so I can continue to program. I can put down print, let's do hello world, very common in the programming world, and it prints hello world. Let's look at types of machine learning. We'll see here there's three types of machine learning, and we'll start with supervised learning. If you remember before, we had mentioned supervised learning and unsupervised learning, and I said there was a third one, which is reinforcement learning. So let's look a little deeper. What is supervised learning? Supervised learning. Machine learning model learns from the past input and makes future prediction as output. Types of supervised learning. The two main kinds of supervised learning that are used today is classification and regression. Classification is concerned with building models that separate data into distinct classes. As you can see, the guy on the left, he has yes, no, very common, true, false. They can have more than two classes, but usually you see a lot of classification where it's two decisions to make. Let this person have a loan or don't let him have a loan. Or in the cases earlier, let them bill to PayPal or don't let them bill to PayPal. Common algorithm used. The two common ones are decision tree and support vector machine. Regression, based on previous input data, the machine predicts continuous output value. And you can see here we have three green bars, and you can probably guess what the fifth one's going to look like. Algorithms used are linear regression and polynomial regression. Those are the two most common ones, although there are certainly many more. And we haven't touched upon neural networks, which is a whole other group of machine learning tools that include both of these. Let's look at supervised learning classification. In this example, we have past data where we might have images of girls and boys. And these different images go into the model training. And once we've tested that and we made sure it works correctly and is what we want, then we can take the new data, which would be a new image, in this case of a girl, and the prediction comes out and labels it as a girl. Then let us take a look at the classification decision tree. In this one, we're making a weekend plan, and the plan is going to depend on numerous choices that come up. The first one is, are the parents visiting? If the parents are visiting, yes, then we'll probably watch a movie. If no, then it's going to depend on the weather. If the weather is rainy, we'll probably stay inside and do something. If it's sunny, we'll probably go outside and play tennis. So you can see this basic setup generates a tree based on what's going on and different information coming in. Let's take a look now at supervised learning regression. In this model, we see we have the past data coming in. In this case, it's the amount of rainfall. It might be how warm it is, what the temperature is, based on what day it is. This information comes in and it says, okay, Thursday the temperature was 55, Wednesday it was 52 degrees, and then it rained when it hit 39 degrees on the following day. Now we've trained this model and tested it. And once it's been tested, we can now then put that same information that's happened like the last 3 days and try to predict what today's weather is going to be based on that information that came in. This is a good view of supervised learning, the regression model. Let's look at another example of supervised learning regression. In this one, we're going to take a look at real estate. Very common use of linear regression. And let's say we're in a market and we know that a small house sold for $1 amount. And a larger house sold for a larger dollar amount. And maybe we have a number of houses we plotted on this, and then we want to know how much is the house I'm about to sell worth based on its size. And so we'll take a line and we'll plot these points and we'll draw a line through those points. That's why it's called linear. And we'll look at the house we're in, and then we can guess where it occurs on that line, how much it's going to sell for. Now, I don't know if you're like me, you're probably ready to roll up your sleeves and start doing some scripting and doing some hands-on. So let's jump into the fun part and see what this looks like in Python code. So here we go. Let's jump in with our linear regression demo and start learning a little scripting in Python. First, before we do any of the work in the Python, we have to import all the tools we need. Now, the basic programming, like x plus y, is part of your basic Python scripting language, but people built these modules that have all the different tools in them already pre-built. So we don't want to rebuild all those. We want them to do the work for us. So we'll start by doing the importing. We're going to import the matplot library, pyplot, and you'll see it as PLT. That's very common to use the PLT term for our matplot library, pyplot. And then from NumPy, we're going to import as NP. That's a number Python, is what that's an abbreviation for. And NumPy is a way of working with our arrays so that they can take our data and format it in a way that our learning kit, our scikit-learn, will be able to use. And then from the sklearn, the sklearn, we're going to import data sets and the linear model. And the linear model uses data sets, that's why you have to import that. And the linear model is what we're actually using to do our linear regression in. It makes it very easy. And then once we've imported their different tools we're going to use, we want to go ahead and load a data set to work with. So we've created a data set here called house price. And you'll see here it's labeled 245, 312, 279, and then we have another array called size. And that one's set to 1400, 1600, 1700, 1875, so on. And they correspond with each other. So the first house price is 245, and that corresponds with the size of a house of about 1400 square feet. And each one of those is 10 items long. And that's very important because this is like an XY plot. So we want to make sure that we have an X for every Y. And then we're going to reshape the input to your regression. And this is a little confusing, so I'm going to come back to here in just a second. And we're going to set size 2 equals NP. Now remember, NP came from NumPy. NumPy is NP. So we imported the NumPy for dealing with our data and reshaping it. In this case, we're going to reshape the size, and we're going to reshape it in what they call a format of -1, 1. So let's do a quick breakout and see what this looks like in Jupyter, in your Anaconda Jupyter notebook. And also see what this size 2 is about. So here I pasted the code up to now in the Jupyter notebook. And I'm going to hit the Run button up here. And you'll see that it comes down, and I actually added a line here that says print size. So when we have the size array, and I print that size array, you'll see it's 1400, 1600, 1700. And then we're going to take and print the size 2 array, the one that we've reshaped. And let's go ahead and run that and see what that looks like, and you can compare the two. The first one is just an array or a row of data. And we've taken that data row, and the -1 means it's going to be, that forms brackets around everything, so it's one large array. And then each row is only going to have one item in it. That's what that 1 stands for. So we've created 10 rows with one item each in an array. Just so you can see what this looks like, I'm going to change this to 10 and run it. And you'll see that I now create an array with one row of 10 items. And then we're going to do this with 5. And if I run that, I create an array with 2 rows with 5 items each. And then we're going to change this to 3. And just a quick guess, what do you think will happen with 3? This is a trick question because 3 doesn't go into 10. And so when I run it with 3, I'll get an error because it cannot break it into 3. It can't break it into equal parts with 3 pieces in each row. Now for this particular example, I'm going to go ahead and keep this as 1 because we do want it to be one item per each row. Let's go back to the regression model that we're working on. Now that we have all our data set up and all our imports done, we need to go ahead and create a variable that is defined for the linear model. And that's where this first line comes in. We take in regr for regression, and we set that equal to the linear model dot linear regression and then brackets. All that does is that takes that module that we brought in and assigns it to a variable. Once we've assigned it to a variable, we want to go ahead and do what they call fit. And that takes the data we have, in this case size 2, and then the house price, and that's going to fit it to a linear regression model. It's going to see how close it can get to that line. And then we're going to print the intercept, and we're going to print the coefficient. And let's take a look at that. You'll see in here where it shows the coefficient output and the intercept output. I'm going to go ahead and do a breakaway at this point and show you what that looks like so you can see what's going on. Now here we are back in our Anaconda Jupyter notebook. And I can put this down below, and this is one of the nice things about this is I keep my script separate so I can test each piece one at a time. And let's put that code we just did in there, and then I'm going to run it. And you'll see here where it prints out the coefficient and the intercept. So we're going to put in size new equals 1400, and price equals the size new times the regression coefficient plus the regression intercept. And when I go up here and I hit the run button on that, we want to print the price, you'll see that I get a value out. So for 1400, that line is going to generate a number 251.92. Another way to do this, and this is very important to notice, although we'll be using the formula in here so you can see what's going on, is you can also do regress.predict size new. And you'll see in here that I've taken the size new and I've put the double brackets around it, because that's the format it needs to see in there. It needs to see a single row, single column. And let's run that, and you'll see it gives the same answer. Now, generally, when you're doing just a simple linear regression, you can use the formula, but when you get to much more complicated machine learning, you'll see that predict comes in and is much more important to use it instead of using the actual formula. Now let's go ahead and get back to where we were, now that we've done our step out. And we're going to come in here and we're going to create a definition. Now, you can create your own definitions, and they can be called from your program and run over and over again. In this case, our def, DEF or definition, is called graph. So whenever we type in graph and we put in two values in that graph, these lines are going to run. And you'll see in here we have in brackets formula and x underscore range. And whenever these are put in here, the first thing it does is it takes an x and it sets it equal to an NP array, a NumPy array. Remember we imported NumPy array as NP. And it does it to x range. What that is doing right there, when you see that specific setup, is it's going to convert that x range array coming in into a NumPy array. Y is going to be an evaluation of the formula. So we're going to be putting a formula in here, and we're going to eval that formula. And that's what y is going to be equal to. And then finally, we want to go ahead and take our PLT plot and add those numbers, that xy in there. So basically, we're taking the x value from our array coming in, and then we're going to evaluate with the formula we're going to send in there also. Finally, we're going to use that definition we just created, and you'll see right here it says graph, and then we're going to send it the following formula, the regression coefficient times x, plus the regression intercept, and then we're sending it a range of 1,000 to 2,700. Now what that range does, what that particular Python command does, is it creates a list of numbers as 1,000, 1,001, 1,002, 1,003, and so on all the way to 2,700. And if you remember that it's going to take those numbers and it's going to plot each one of those based on the formula that we've created through our regression coefficient and regression intercept. You'll see right back up here where we did the definition. And this is where we have that eval, the formula, coming in. So once we've done that and it's put all those dots on our PLT, our plot, then we're going to add one more setup on there. We're going to do a scatter plot. And on there we're going to put the size, the house price. Remember our original data? We're going to put that right in there. And then we're going to put those in black dots. And then finally we want to go ahead and add some labels to our plot. And you can do that simply by doing the plt.y label. And in there in brackets and then in single quotes, you'll see house price, and then you'll plot the x label with size of house. And then finally we want to see it, so we'll do the plot.show command. And as you can see below, our definition created that nice blue line down the middle. And then there's the actual data that was used to generate that line with the different that we originally imported in. Time for a quick breakout. Let's go ahead and see what that looks like in our Anaconda Jupyter Notebook. Let's put that last piece of code down here, and I just happen to have it saved, so I'll paste it right in there. Come up here to the run, and you can see just like we expected, it's generated this nice graph with the blue line, and you can easily see the different plots from our original data that generated that linear regression model. Now that we've gone through a basic setup of linear regression, and you've seen how to do some basic plotting, you can always play with those numbers and try some different numbers in there or create your own and see what you can create. Let's go ahead and move on to the next topic. Unsupervised learning. Let's take a closer look to see exactly what that means. Unsupervised learning means that the machine is learning using unlabeled input and allows the algorithm to act on that information without guidance. So if you remember when we did the supervised learning before, we had an answer and we trained it before we started putting in unknown data. In this one, we don't have an answer. We're going to let the algorithm create the answers for us. In unsupervised learning, we take a lot of raw data, we put it into the algorithm, and you can see in this case we're using pyramids and cubes and ovals, and then the algorithm looks at that data and creates its own categories or creates its own ideas of what that output's going to look like. We don't have to tell it what a pyramid is or what a cube is, it guesses. The major types of unsupervised learning are clustering and association. Clustering is used for analyzing and grouping data which does not include pre-labeled class or even a class attribute at all. The most common algorithm is the k-means. Two other common algorithms used for unsupervised clustering is the hierarchical clustering and the hidden Markov model. Association discovers the probability of the co-occurrence of items in a collection. The most common used algorithm for that is the a priori algorithm, and there's also the FP growth algorithm. Let's take a closer look at unsupervised learning and clustering. And the basic idea of clustering is we're going to take similar items and cluster them together and move dissimilar items into their own group. In the k-means clustering, the first thing we need to do is randomly initialize 2 points called the cluster centroids. And usually you pick them anywhere on the graph. You want to do them randomly so they're not in the same place. Now, based upon the distance from the orange cluster of the centroid or the green cluster centroid, it'll group itself into that particular group. Once it's grouped itself into that particular group, we want to make some adjustments. We want to move the centroids around just a little bit and then regroup them so they're more optimized. We're going to keep repeating that, and we're going to iterate that till the cluster centroids stop changing their positions and become static. In other words, when the points seem to form best around the two centroids and seem to have their own groups, very distinct groups, once the clusters become static and there's no more adjusting or moving around, that algorithm is said to be converged. You'll hear the term converged in most machine learning. So when we talk about our machine learning tools, converged means it's done. It's finally found a solid point. And then you can start testing it and then using it in your real world usage or commercial use. Before we look at the actual script, let's take a look at a case study and what that looks like in real life. Let's say you have a hotel chain and wants to establish its new delivery centers across the city in the most optimized way. Now, I don't know about you, but if I owned, which I don't, but if I owned a hotel chain, I would want to maximize the position for the best way of making money and the least amount of cost. So in this case, some of the possible challenges that are going to come up is we want to analyze the areas from where the food is being ordered frequently, to figure out the optimum number of hotels required to cover the city area, to figure out the optimal hotel locations to minimize the distance between the hotel and the delivery points. This gives you an idea of one of the uses that they use for different clustering on there. You start clustering these different things together until you find where is the optimal place to place a hotel. Now, we're not going to dig up all the data on hotels and the logistics of movement to different areas, not for a basic learning example. Definitely something you'd want to dig into in a situation like this. But let's keep it simple. Let's roll up our sleeves and let's see what a k-means clustering looks like in Python script. So here we are with our demo on k-means clustering using Python. And just like before, we want to start by importing numpy as np. Very standard for using our numpy arrays. And we want to import our matplot library, pyplot, as plt. Again, very standard because that's how we're going to plot the data so we can see what it looks like. And then from the matplot library, we're also going to import style, and we're going to use a style called ggplot. Now, don't worry too much about that. That just makes it look nicer, and there's a lot of options. We're not going to go into all the different options you have in the matplot library. You'd have to look that up. But it certainly has a lot of uses in there. This just gives you an idea that there is more to it than just the matplot library. And finally, from the sklearn cluster, we're going to import k-means. Once we've done all our imports, we want to go ahead and set up some data to use and play with. So we're just going to take some random numbers in this case, and I'm going to set x equal to 1, 5, 1.5, 8, 1, 9. And we're going to set y equal to 2, 8, 1.8, 8, 0.6, and 11. Now remember, the 1 and the 2 go together, so it's 1 comma 2, x1, y2, x5, y8. And then when we take and we do a scatter plot of that, you can see it puts a nice little set of dots across our graphs. You have a nice output of it. Let's just do a quick breakaway so you can see what that looks like in the Jupyter Notebook. Let me go ahead and put that code in here. We'll come in and hit the Run Script button, or Run Cell, select below. And you can see it does a nice plot just like we showed you. So now that we see what the data looks like, the next step, just like we did before, we have to convert the data to an NP array, or a NumPy array. And you'll see instead of shaping it, which we could have done, we went ahead and just created a double bracket so you can see what it looks like if you don't shape it. And you'll see there that we put a brackets around, and then you have each point, 1 comma 2, 5 comma 8, 1.5 comma 1.8, so on and so on. And we're going to label this as X. And then the next step is we go ahead and create our cluster variable. And in this case we called it k-means, all lowercase. And you'll see that it equals k-means, which is the module we brought in. And we're going to send it a variable to it called in_clusters, or in_clusters. And we're going to set it equal to 2. That's how many clusters we want to make. Now that is one of the challenges when working with k-means, is guessing how many clusters you want. That's why it's nice to always plot the data first, because then you can guess what how many clusters you want and then set it accordingly. And then once we've done that, we very simply do a k-means.fit x. And that takes our x data that we just plotted and fits it to the k-means and creates those different pieces of data we were looking at earlier. So here you see it. We can set a variable called centroids, and we can set it equal to our k-means variable dot cluster centers. And that's part of the k-means module, is you have cluster centers and you have labels. So we can create both our centroids and our labels. And when we print our centroids and we print our labels, you'll see down here the output. The output is the first centroid is going to be located at 1.166, 1.4666. That's where the first point is, and then the second centroid is at the 7.333 and 9. And then the labels, that tells it each of those different pieces of data we put in, it says which centroid that's going to go with. So the first one is 0, and the second one goes with 1, which is the second centroid, 0, 1, 0, 1. And that's how it groups those different points of data. To keep a nice continuity, let's go ahead and do a breakout. And let's go into our Anaconda Jupyter Notebook. And you can see here where we did our final show. And let's scroll down here and paste this last piece of code in here. And then we'll go up and hit the Run button. And you'll see right there is our 2 centroids, and there's our labels we have for each of our data points. One of the things I'd like you to notice at this point and take away from this is that in both the linear regression and in the k-means clustering, there's not a whole lot of programming. It's very easy. So if you were scared to do a clustering, you can see that within a couple lines of code, you can do the clustering. And now we're going to go ahead and show you how to print the clusters onto a graph. So let's move on here to the plotting and visualization of the output. And we're going to go ahead and do the colors again. In this case, you can see we use kind of a standard color scheme. A lot of times when you do a project, you want to pick the same color scheme or general color scheme so that everything kind of goes together on there. And in here, we're going to go through the range of the length of x. So we're going to look at each of these x variables, and then we're going to print the coordinate of x of I, and the label, so we know which coordinate goes with which label. And then we're actually going to plot them. So for each one, we're going to add that to the PLT plot. And then once we've done that, just to kind of make it fun so you can see where those centroids are, we're also going to add the scatter plot and put the 2 centroids on those plot. And then once we've done that, we'll go ahead and do a show so you can see what that looks like. Now, when you're looking at this, some of this might look a little confusing. So let's break down just a couple of these pieces. The first one I want us to look at is the plt.plot. In here we have xi of 0 and xi of 1. Now remember, we have to plot x's and we have to plot y's. We have to send those as individual arrays. One way to do that is to do x of I. Remember, I is in range of length of x, so it goes 0, 1, 2, 3, 4, 5. So we look at the first one, and we look at just the value 0, and we look at the second one, and just the value 1. This is an abbreviation. And it's actually sending all of the x coordinates in one array and all of the x coordinates in the second array. And it's plotting each one of those dots. And then for the colors, we want the colors to match the label. So if it had a label of 0, it's going to be green. You can see that G dot up there being in the very first position, the 0 position. And if it has a 1, it's going to be red, which is the first position. Or you actually count your arrays from 0, 1, 2, 3. So it's the 0 position and the 1 position. And then finally we've added a marker size equals 10. That is something you have to play with when you're playing with the plots. Usually 10 is a good size for a marker, but you might find that you need more points, a 20 point or a 5 point depending on what you're publishing it to and how you want that to look. And then second part I want you to look a little closer at is the PLT scatter. And you'll see here we have centroids and then it does the colon comma 0. And so when it does that, that again is the abbreviation looking at just the first part of the 0 in that array. And then the centroid colon 1 is going to be the second centroid. Remember we go 0, 1, not 1, 2 in our arrays. And then we set the marker equal to x, because instead of being a point or a dot, we want the centroids to show up. We want them to look differently. And we made them larger, so we put s equals 150. And the reason we use s equals 150 instead of marker size is because that's a font size setup. And then finally we have line widths and z order. Don't worry too much about those. You could actually take those out and it would still work just fine. But we're going to leave those in because it makes it look a little nicer. And finally you have the plot show. And when we put those all together, you'll see that it prints out the coordinates and each of the labels that go with that coordinates. And on the right, you have a nice view of what that looks like. We have the 3 dots that go with the first centroid, or the centroid in the 0 position in the array, and we have the 3 dots that go with the centroid that's in the 1 position, or the other centroid in there in our k-means clustering, which remember we set to do 2 separate clusters. Now, it wouldn't be right if we didn't do a quick breakout and show you what this looks like in the Python Jupyter notebook. So here we are in our notebook. I'm going to put the code in here. I'm going to go up here to run script, and as you can see we have our coordinates all printed out and the nice graph down below with our 2 centroids on it. Now that you've seen the scripting involved for the program, let's take a quick look at a simple use of how this works and what it's used in commercial use. Here we have a customer who's going out and buying bread, milk, an apple, it looks like some lettuce in the back, another customer who's brought some water, an apple, some bread. And if we have a third customer who picks up a loaf of bread, what do you think they would buy with that bread? Well, you'd be right to guess. If I was looking at this, I didn't know anything else, I would guess that they're going to buy an apple with it. And this is great if you're in a grocery store and you want to put stuff together that helps people, you're marketing to them so they're going to buy what goes with it. So you put peanut butter next to jelly because people who buy peanut butter are probably going to buy jelly. People who might buy noodles might buy sauce to go with it. So this kind of grouping, some of it might be very intuitive, some of it you might never have thought of things that go together. And so this is a great and very powerful tool used in marketing today. Let's talk about reinforcement learning. If you remember from before, we looked at supervised learning, where we had data and answers put in there and we trained it from our experiences. We had unsupervised learning, where we're categorizing things and finding out what goes together. Now we're going to look at reinforcement learning. Reinforcement learning involves teaching the machine to think for itself based on its past action reward. So here's kind of a fun example. We have Mario Brothers, who can move left, right, or up and down. And as you go through the game, it performs an action. And in that action, maybe it gets the reward of the mushroom because it went up and jumped and landed on the mushroom. Or it performed an action where it landed on the villain, and in this case you lose a life, your punishment. So this is reinforcement learning. We start trying to go towards what rewards us, and we move away from punishment. And that uses the feedback from whatever we just did to learn what we're going to do next. And so the algorithms most commonly used with this is Q-learning, temporal, difference, TD, deep adversarial networks. Now that we've looked at the 3 major areas of machine learning, and we've done scripting in 2 of them, we're going to take a look at the use case study of weather analysis. to give you an overview of what goes into setting up one of these databases and what a work environment looks like in a lot of cases. The first thing is we want to state what the problem is. The problem is to predict the weather conditions using machine learning. And the possible challenges that come up are to identify the areas which are exposed to rainfall. Considering the temperature and pressure as parameters, K-means algorithm will identify the regions which are expecting heavy rainfall. So this can be really important if you're worried about flooding, especially in today's world. We've had a lot of floods of recent. And so the data set that was being used in this has 3,000 entries, and they assume a K equals 3 in this case. We had light rainfall, medium rainfall, and heavy rainfall. And so the first thing is they downloaded the data set with the 3,000 entries. And once we take those 3,000 entries, let's take a look at the script behind the weather analysis. Now, we're doing something a little different here. And if you don't understand everything going on, that's okay. And I'll explain why in just a second. So first we have our importing of the libraries. A lot of that should be familiar from our other two scripts we did. We have our matplot library in line. It's a little bit different, but we have from copy import deep copy. Deep copy allows us to copy arrays instead of just using pointers, because a lot of times in Python when you say an array A equals array B, it points to it, but we want to actually copy all the different variables into A. That's what deep copy does. You should recognize import numpy as np. We've added a new one in here you haven't seen before, which is import pandas as pd, very commonly used for importing data into your program from a file. And then we have our from matplot library import pyplot as plt. Again, very common. We've seen that now a couple of times. And then we have two different formats for the plot that we're using in here. We have plt.rc params, and we're setting the figure size. That just limits the size of the figure. Don't worry too much about it. It's one of those things you kind of play with when you start playing with graphs, is you notice that there's figure size and there's other settings in there. And then because we're using very large data, it's important to bring it down to a smaller size. Otherwise, it'll take up your whole screen. And then we have a plot style and use. And again, we went with the ggplot on here. Now, the one thing I want you to notice on here that's missing from when we did k-means before was the k-means library from sklearn. What we're going to show you here, and this is why I don't want you to worry too much if you get a little lost, is what it looks like when you don't use the sklearn. Now remember, the sklearn took a couple lines. We told it how many centroids we needed, and then we let it do the rest of the work. So in this example I'm going to walk you through, I'm going to show you what it looks like if you don't use the sklearn clustering program in there. Let's take a look at the data. And in this case, they used Panda to import the data. And this is a wonderful tool. So if you have saved a CSV file, comma-separated variables with your data in it, you can now easily import that into your program using the PD, the Panda. And in here you can see that Panda recognizes that there is the header line, and then it also recognizes how much data is in there and breaks it up for you. So in this case we did print data.shape, and you'll see that there's 3,000 different entries in this data set that they used for this example. And when we do, and it has the 2 means there's 2 columns, and that's represented in here with the 2.072345 and the minus 3.241693. And when you print the head out, data.head, and you can just type in, if you're in Jupyter, you type in data.head once you've read your data in. It'll print out what you see here, just the header on there and the line number and the different data associated with it. So you have your temperature difference, your pressure difference, and you have line 0, 1, 2, 3, 4, and the head only prints out the first 4 lines. Kind of a nice way just to glance and see what kind of data you're going to look at. And this is a nice introduction into Panda, a really wonderful tool in the Python library. Now, once this has been imported, again, we're still looking at stuff you've seen that should make a lot of sense. F1 equals data, and because of the way Panda imports it, it labels the data. So I can very easily say F1 equals data temperature difference dot values. That's what Pandas does. That's all Panda on there. And F2 equals data pressure differences dot values. So basically I've created my XY. In this case it's F1 and F2. And then we're going to come down here and we're going to take x equals NP array. That's your NumPy array. And we're going to create a list. And we've done something just a little different here. You'll see where it says zip F1, F2. That takes and that combines the F1, F2. So you have a list of the first values, the second values, and so on. We'll come back to that in just a minute here in the next setup. And then, of course, we just go ahead and plot the F1 and the F2, or the XY, the temperature difference versus the pressure difference. And they set the color for black, and the size is 7, so each dot is a size 7. And if you look at it, the first thing you notice is it groups into 3 nice general groups of data. And that means that when you're going to start doing the k-means kind of clustering, you want to do it to 3. That's pretty clear on there when you look at that. And then we're going to take a little detour. And this is where it starts to get a little confusing. And this is where I don't want you to worry too much about it, because we're showing you what's under the hood of k-means. This is what's going on. The first thing is we create a definition, which is a distance. And this is just a distance between 2 points. And so if you have 2 points that are, x, y, 3, 4, 5, 6, if you remember from your geometry, Euclidean distance just draws a triangle, and it's that line of that long edge of the triangle. That's all this is calculating on here. And then, of course, we already talked about number of clusters, so k equals 3. And then if you remember with k-means, it generated the centroids for you automatically. Well, under the hood, what is happening is it goes in there and it creates the x-coordinate, and it creates a random one. In this case, it creates 3 of them, and it creates 3 random y-coordinates. And it takes and does it between 0 and the max value of x, minus 20 in this case. They don't have to be minus 20 and usually don't start at 0. But that will work fine for this example. Like I said, this is under the hood. So if you get a little confused on there, don't worry. You don't need to know this if you're actually using the k-means or the sklearn on there. But knowing what it's doing is important. And in this case, we put them into a NumPy array. So that's what that NP for NumPy. And then it's a dot random integer. So we're going to create a random integer. And it's between 0 and the NP max. And we're creating 3 of those. So it's an array 3 wide of 3 random numbers. And we do the same thing for y. And then finally we create our centroids. And we do that by combining the x and the y. And that's where this NP array list zip c of x, c of y comes in. It combines each of the x and the y's and pairs them together. And then you have your d-type equals np.float32. Well, float means it's a floating decimal. That's all that means, is we're turning it from an integer to a decimal. Now there's an actual, you got to be a little careful in Python because float means something a little different than decimal. But for the very basics, you usually use float with most of the machine learning, and you just kind of assume that that's going to have a decimal point and the value has a floating decimal on it. That's where the float comes from. And then if we print C for the centroids, you'll see on the right-hand side we have our 3 centroids that we've generated with a random integer turned into a float variable. Now, once we've done that, we're going to go ahead and plot a scatter plot of F1 and F2, our original data. And we're going to do that. And the C, again, C just stands for color. So the color number 050505 is a very dark color. It looks pretty black to me. And we're going to plot scatter the CX and CY. CX was all the X centroid markers, and CY is the array of the Ys. And we're going to put those as stars. And if you squint and kind of do a find the star in the picture, you'll find the 3 stars in there. One of them sticks way out there in the upper right. If you look just a little bit below it, there's another one, and to the left, in between those 2 is the 3rd one in the middle of that top cluster. And again, you see C equals G, so we set the color green so they're easy to find. So then we need to go ahead and store the values of the centroids, so when it updates, it changes those shapes around. So we have our centroid old equals the NumPy array of zeros of C shape. That's just taking our current C centroids and moving them into a stored array so we can get back to it if we need to, when we need to. And we create cluster labels np.zeros. They say length of x, so we have 0, 1, 2. That's all that's doing, is creating 0, 1, 2 in the NumPy array. Then we have an error function, which is the distance between the new centroid and the old centroid. And if you remember, we created the Euclidean distance formula, so you have like your new xy coordinates for the new centroid and your old xy coordinates for the old centroid, and that's going to create an error. What's the error between them? What's the distance between them? And so we initial that error, and then we're going to create a loop. And the while loop is a Python command, and it says while error is not equal to 0. So long as we have an error, as long as it's not equal to 0, I want you to do what's below. And then during that loop, the first thing it's going to do is it's going to go for I in range of length of x. So it's going to go through all of the coordinates, and it's going to figure out the distance from that coordinates to the centroid. So you can see here distance equals distance of xi comma c, and then it's going to cluster equals np argment distances, and then clusters of I equals cluster. So we're basically taking each one of those points and we're assigning it to one of the centroids and forming one of those clusters. We're not really assigning it to a centroid, but we're assigning it to a cluster. And then the centroid is center of that cluster. And then we take the old values, and you have to do a deep copy. Remember we talked about that earlier. If you have arrays, you can't just copy one array into the other. You have to do a deep copy to have all the values moved over. So we're now taking the centroids that we currently have, and they're now the old centroids. And then we want to find a new centroid value, so we're going to adjust that centroid a little bit. Remember before, we're moving the centroids around until we got the right fit. So for in this, we do for I in range of k. Again, we're going through the values, 3 centroids, so we're going I with 0 through 2. 0, 1, 2 is how that actually reads. So there's 3 values in there. And then your points equal x of j for j in range length of x. And then we have if cluster j equals I, c of I equals np mean, points axis equals 0. Wow, that's a mouthful in there. So let's take a quick look at that. And again, this is pretty under the hood deep stuff. So if you're just going to do a basic k-means, you can use the formula from the sklearn module instead of programming it yourself. What we have going on in here is if your cluster and your distances are connected correctly, and it looks at the mean of the points and the axes equals 0, then c of I is going to be equal to that. And then we create a new error in there. Again, the error is based on the distance. And then finally, we take the colors, R, G, B, Y, and C, and M. You should recognize this from before, red, green, blue, a little bit different order, red, green, blue, yellow. And we take our figure, and our axes equals PLT subplots. And this is very advanced. Again, if this is a little confusing, that's okay. Most of this you don't need to do a basic k-means. We're just showing you what's under the hood. And so when you take the figure and the AX and the plot, those are 2 different parts that you can do in plots. We can then plot the points onto those. And as we go down here, we create our points for j in range of the clusters, and then we create our scatter points, and we go ahead and put those on there just like we did before from the k-means. And then we also put our markers so we know where our centroids are. So that's where the AX scatter is. And what we end up with is these 2 nice maps of pressure differences, and you can see the centroids are now done in black. And the blue region with the highest temperature and lowest pressure will have high rainfall. So you'll see that nice blue region in the bottom right. That's when they're going to be worried about flooding. And comparatively, the red and green region will have lesser rainfall. So once you know which area or cluster you're in from that data, you can predict what's coming in and how much to worry about the rainfall coming in. So you can see in here one of the common uses of weather analysis for using clusters. And you can certainly figure out a lot of reasons in your daily life if you start looking around and seeing where in business people want to be able to cluster data together, whether it's marketing, weather analysis, whether you're working out the logistics of getting food to a restaurant. All of those come together, and the k-means is a very powerful tool for doing clustering and doing machine learning in clusters. Let's take a look at the key takeaways for this. We studied machine learning workflow, where we learned to define an objective, prepare the data, collect the data, select the algorithm, train the model, go back and test the model, see if that worked. If that didn't, take a look at the training of the model and make sure that was correct. And if that still wasn't correct, go back and select a new algorithm to come up with a prediction and a commercial grade output for our machine learning workflow. We looked at types of machine learning. Supervised learning, where we have the data and the collections and the answers to train our machine learning tools. We had unsupervised learning, where it doesn't know what the answer is, but based on its own ideas, groups things that are like together. And then we took a quick look at reinforcement learning. Finally, we looked at types of supervised learning and types of unsupervised learning, where we looked at classification, regression, we looked at clustering and association, and then we took a look under the hood of the k-means and what that looks like in our use case with the weather analysis. Thank you for joining us today, and for more information you can visit www.simplilearn.com.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.